So, for this equation, we shall be having some questions and solving quadratic equations with the nature of roots. So we can determine the nature of roots, and we shall be having three questions where we can actually analyze three different scenarios. And we all know that the scenarios of a quadratic equation, as you all know, is we have to look at the discriminant value. So I believe before this topic, we should have been able to see, or we should have discussed the discriminants of the quadratic equation, which is from the general quadratic formula. It is basically b squared minus 4ac. So this factor here determines the nature of our roots. So we have three different conditions that has been stated. We have 3 b squared minus 4ac is greater than 0. There we can have two roots here, or we can have b squared minus 4ac is equals to 0. Here we can have same roots. We can have same roots, one roots that are the same. And then we can have b squared minus 4ac is less than 0, and there are no real roots. Or we can say it is imaginary. So basically, from the questions, we can determine by picking the conditions of our discriminants or this factor here, and then we can use to solve or find the missing value. Now, every factors or every variables in a quadratic equation is very, very important. So as a matter of fact, we have to consider every detail while we solve our quadratic equation. Okay, so the first thing we have, let's take question 1 and see how we can solve this quadratic equation. So the question is that the equation x squared minus 4x minus 1 is equals to 2k, parenthesis x minus 5, where k is constant and has two equal roots. Find the possible values of k. So the condition stated here is that they have two equal roots. So looking at this, basically, we can basically analyze this question that k has two equal roots. So how then do we find the value of k when it has two equal roots? Okay, so when we have this question, what we have to do first is to select the quadratic equation or the formula or which of the discriminants or the nature of roots that describes our quadratic equation. That is the first step that we have to do when solving the quadratic equation. So the first thing that we have to do is to select the condition. So we know that this one has what? Equal roots. So because the roots are equal, they are 1 or they are equal. So we are going to select this condition because we know that they are equal. So allow me to create a space down here. I'll just write my condition here and solve the first question to the left side. So my quadratic equation is basically x squared minus 4x minus 1 is equals to 2k, my parenthesis, x minus my 5. So I'll just clean this off so it can be very clear and visible. Minus my 5 is equal. So, and the condition selected here is this one. So basically, I'll write my expression bx squared minus 4ac is equals to 0. Now, the very first step that I have to do is to rearrange my quadratic equation in the form of ax squared, this is the general form, plus bx plus c is equals to 0. Rearranging my quadratic equation helps me to identify my coefficients, my a, b, and c, where I can substitute in my condition and then find the value of my k. Okay, so the first thing once again is to rearrange my quadratic equation. So I'll have, from this quadratic equation down here, I'll have my x squared minus my 4x minus my 1 is equals to, let's expand this one and see what we'll get. 2kx minus, if you multiply this together, you'd get negative 10k. Now let's take all of this to the other side and see what we're going to get. So let's have one general quadratic equation. So we can have from this part x squared minus 4x minus my 1. This one coming here, 2k becomes my plus 2kx minus my 10 plus, right, actually my 10k, all equals to my 0. So let's rearrange this and see what it has. So we have a k here and k in order for us to get our b. So we can have our x squared minus my 4x plus my 2kx, okay, plus my 10k minus my 1, all equals to 0. Now let's see what we can do. Let's see if we can try and factor out our quadratic equation from this side. So forgive me if I just push up because I want all the solutions to be written down and you guys can also follow. Feel free to pause the video anytime and solve the questions on your own, just to make sure that you are in line with what exactly what we're doing or how we solve these equations. So next step is to factor out. So if you factor out, let's factor out the common terms, just like we do quadratic equations when we solve quadratic equations by factoring method. So we can have from this part, just to identify this, we can have my x squared minus, if I am to bring something out of here, I can bring out my x. X is very much common here. So I can bring out my x, okay, and I'll have negative x, and I'm going to have my 4 plus my 2k plus, obviously there's nothing here I can be, so I can make this one single entity, minus 1 is equals to my 0. This equation can further be written as, if you follow closely, I'm just going to take this x to the back here. It's the same thing, I'm just rearranging this equation. So I can have, so I'll just remove this so it can be clean. So maybe I'll just have a different color. Just taking this, driving this guy here to the back. So we can have my x squared minus my 4 plus 2k, having my x now at the back, which is the same with this one here, plus my 10k minus 1 is equals to my 0. Looking at this equation now tells you that I have my quadratic equation already. So I'll just create more space here so we can solve this equation. This is where we are. Okay, so from this part here, if I write my quadratic equation, if it does have more space, I can have my ax squared plus my bx plus my c is equals to 0. As you can see here, I know the value of my c, I know the value of my b, and I know the value of my a. So I'll just go ahead and write it. So my a is 1. X squared have a coefficient of 1. And then my b has a coefficient of negative 4 plus 2k. And then my c is equals to my 10k minus 1. So all of this now falls into, remember my previous conditions, that they are equal. What condition do we look? I'll just drag this equation down so we can look at the condition. So our condition here, remember, I'll use a different color, is our b squared minus 4ac is equals to 0. So those values that we have obtained now is what we're going to use inside of this equation. Okay, so maybe I'll just write it down once more just to make sure that we're all together. So my condition once more is my b squared minus my 4ac is equals to 0. This is my condition, and this is what we're going to use to determine the values of k. Next, I'll substitute my ABC inside this condition. So what is my b squared? My b squared is my negative, okay, do not forget your negative sign, very important, plus my 2k, have everything is all squared, including the negative sign, is minus my 4. What is my 1? My a is 1, and my c is 10k minus my 1. All equals to 0. I've successfully substituted for all the values of A, B, and C inside of my condition. Now, evaluating this one here, my first equation can simply be my 4 plus 2k and 4 plus 2k. You're asking me why I didn't put this negative sign? Because negative, negative gives you positive. So automatically, the negative sign is gone. Okay, so the next thing that I have to do, so I'll just remove that part of it. So we can have minus, let's solve it one after the other. So I can have this one here, minus my 4, I can have minus my 4, 1, and my 10k minus 1, all equals to 0. I'm trying to solve this equation as easy as possible so we can most likely understand the process, and if ever there will be missing variables inside of my quadratic equation. Feel free to type in your comments if you have questions on how I solve my quadratic equation. So from this part, if you use the FOIL method, you can have, remember, all you have to do is multiply this, the FOIL method, by this, the same thing. So I'll just use colors like this. We can have this one here and the second one like this. So basically, what we're having is 4 times 4, that's 16, plus 8k, plus 8k, plus 4k squared. If you go further, we can have our minus, open my parenthesis here, just to solve this one, we can have 40k minus 4, all equals to 0. So if this minus 1 here multiplies everything here, and let's solve this first. So we can have, and rearrange rather, let's rearrange our quadratic equation and see our value. So we can have 4k squared, 8 plus 8, that is 16k, plus 16, plus my 16, okay, and then we have our minus 40k plus 4 is equals to 0. We can actually still reduce. Looking at this equation simply means that we can actually still work on this equation to further simplify this equation. So we can have a 4, I'll just remove this so it's not too dark for us to see. I can have my 4k squared, 16 plus my 16k. So we can have 16k and 40k. So plus 16 minus 40 gives us 24. So negative 24k. We have a 16 here, plus 16 and plus 4 gives us plus 20 equals to my 0. So now we have our quadratic equation, and then we can use that to determine our value of k. So allow me to use another color, and I'll highlight this so you can solve it on your own and determine the value of k. Whatever method that you decide to use here will actually help you solve this equation. So for me, I can decide to simplify this equation by dividing all through by 4. As you can see, everything is a factor of 4. So I can say 4, I'll just write it here, just to remind everyone, divide all through by 4. If you don't want to divide by 4, you can as well just solve the equation that way, and you end up getting the same thing. But I'm trying to make my equation as simple as possible. So we can have 4k squared divided by 4 minus 24k divided by 4 plus my 20 divided by my 4 is equals to my 0 divided by 4. Remember, like I said, you divide everything by 4. If you go further here, you can have k squared now being left alone minus 6k plus 5 is equals to 0. So at the end of the day, you can end up having this quadratic equation, and we can solve this equation using any of the quadratic method. Let's say we decide to use our factoring method because we're not done determining the value of k, the factoring method. You can use any quadratic method to determine the value of k. Okay, so from this part, having this, we find a number that we can multiply. Here, let's find the number that we can multiply. So that is k, our coefficient AC is 5. Okay, and two numbers that we add is -1 and -5. And we'll have -6, which is equal to our B. So our AC is 5. Remember, my A is 1 and my B is 5. So two numbers that I'll add that will give me -6, which is my B, is 1 and 5. -1 and -5. So I'll just go ahead and substitute. It doesn't matter the order of how you arrange the number. So I can have k squared minus, so I'm basically going to substitute minus 1k, okay, and minus my 5k plus my 5 is equals to 0. As you can see from this part here, this is also equals to my -6k. So that means I have not changed anything yet. Okay, so I'll just remove this one so I can go ahead and solve my quadratic equation. So as you factor out, you realize that we can have k here being substituted out, and we can have k minus 1, and we can have -5 here, and we can have k minus 1, all equals to 0. So what is now my value for k? My value for k here can be k minus 5 is equals to 0, or k minus 1 is equals to 0. So therefore, k is equals to 5, or k is equals to 1. So these two are my values, my possible values of k that will satisfy my condition that b squared minus 4ac is equals to 0. Remember, we're trying to satisfy this condition. So that's it for question 1. So let's go down to question 2 and see the possibility of solving question 2. So forgive my pattern of how I solve this equation. Okay, so now let's go over to question 2 and see how we can solve question 2. Feel free to try solve question 2 so you can actually have a clue of how it actually is. So for question 2, the question says find the range of values for which the equation 2x squared plus 5x plus 3 minus k is equals to 0. Remember our condition, it has two real roots and extinct roots. Remember, we have two real roots and they are different. Now, which conditions from this guy here towards the right has two real and distinct roots? As you can see, the first condition satisfies it. So I'll just use the blue rather, to mark it out. So this is the condition that we're going to use to satisfy our question 2. Remember, you can always pause the video at any time. So I'll just go towards the left and I'll try to solve the question towards the left side. So my condition here, using the black rather as well, is my quadratic equation rather is my 2x squared plus my 5x plus 3 minus k is equals to 0. So what is my condition? My condition is b squared minus my 4ac should be greater than 0. So whatever my value would be for k, this condition should be satisfied. So this k here, because we're looking for the value of k, that would make my equation, my quadratic equation, satisfy this condition in blue. Okay, so now let's see what our a, b, and c can actually be from this equation. So I'll write my equation again. and we can write the general quadratic equation, and then we can substitute directly. Okay, if you're lucky enough, your quadratic equation can be in a simple form already. You may not have to simplify anymore. Just find the value of all the coefficients of the quadratic equations, and then substitute directly into your formula. So my quadratic equation once more is 2x squared plus my 5x plus my 3 minus my k is equal to 0. Let's write the quadratic equation. So we have my ax squared plus my bx plus my c is equal to 0. I can make this my c because my k is at the c part of my equation. Alright, luckily enough, this equation is much more easier, as we can see. So we can have our a, which is my coefficient of x, which is 2. I can have my b, which is my 5. And I can also have c, which is equals to 3 minus k. So let's substitute that in my conditions of quadratic equations and see how well we can solve that equation. Let's determine the value. What is the possible value of k in our equation? So let's have my b squared. My b squared is 5. So I can just say 25, but I'll just make it 5 squared first, so we can actually all follow together. Minus my 4. What is my a? My a is 2. And my c is my 3 minus my k, equals to, or should be greater rather, than 0. So this is how we're going to solve this equation now. So forgive me once again for dragging this equation to the bottom part of my equation. So our 5 squared is 25 minus, what is 4 times 2 times 3 minus this? So if you have all of this here together, let's try to do this first. Let's multiply 4 and 2. So that is 8. Open, we have a parenthesis, 3 minus k should be greater than 0. So 25 going further, negative 8 times this, that's negative 24. Minus or plus 8k should be greater than 0. Let's try as much as possible to make k positive, so we don't have to flip anything to any side. So let's take these guys to the other side. Let's take both guys here to the other side of the equation to determine our value of k. So looking at this equation here, we can take both guys here and let's determine our simple value of our k. So we can have here 25 minus 1, that is 1. 1 plus 8k should be greater than 0. If you continue to solve this equation here, you realize I can flip my a to the other side. So I have my 8k, which is greater than 0 here, minus my 1. So what is my value for k? So 8k is still greater than my negative 1. So k, or 8k divided by 8 from both sides, greater than minus 1 over 8, tells you that my k value should be anything, okay? Anything greater than, my k should be anything greater than negative 1 over 8. This is what my value of k should be. Anything greater than negative 1 over 8. So that means if I'm to draw a number line here, a number line to determine what my value of k would be. That means if this was my k here, so that means anything greater than negative 1 over 8. So let's say this is negative 1 over 8. Negative 1 over 8. Let's try to make it smaller so we can actually. Negative 1 over 8. If this is my negative 1 over 8, towards the left side, we know we're going to the negative side. And towards the right, we know we're going to the positive side. So in other words, I can change this to fraction, to decimal, and so I can also determine what the value would be. So it's going to be 0.125. It is going to be 0.125. So I can have here negative 0.125. So that means going further, aside from 0, that means after this part, we can have a 0. So from here, we can have 1, we can have 2, we can have 3. So that means my k value should be anything, I'm going to use blue color, from 0.125 to 0, that means 0.12524 from this part to infinity. So anything greater, k is anything greater than -1/8. I hope that answered this question for this part. Next, we can go over and solve question 3. So that will be our last problem set for today. Good thing we still have the same equation, but something is happening. Here we have a 7x, rather. So for number 3, feel free to try, pause the video, and try to find the answers before we get there. So the solution for question 3 says find the range of values of k. We're looking for the range of values of k for which the equation 2x squared, okay, plus 7x plus 3k is equals to 0. Has no real roots. So what is the condition that we have to take? So going back once again to our conditions that we stated here, we can take the third condition. I'll use the red color to signify the condition. We can use this one. So k value should be less than anything less than 0. b squared minus 4ac is less than 0. So I'll go start and write my equations here so we can go directly and solve, substitute rather. So my equation is 2x squared plus my 7x plus 3k is equals to 0. My condition here that we're selected that we know based on the discriminant is b squared minus my 4ac should be less than 0. So if we go further, let's identify what a, b, and c is, and then we can gradually solve our quadratic equation. Let's try to remove this one here so we don't actually get anything included in our calculations. So once again, my equation 2x squared plus 7x plus my 3k is equals to 0. So my ax squared, my condition as usual, my bx plus my c is equals to 0. So what is my a? Is a coefficient of x squared, which is 2. My b is a coefficient of x, which is 7, and my c is just 3k. So what could my c possibly be by solving my quadratic equation? So my b is my 7 squared using this right here. Remember, we have to use the same condition when we solve. Minus my 4. What is my 4? My 4 and then the a. What is my a here? My a is 2 and my c is 3k is equals to, should be less than 0. You have to make sure that you're actually following the conditions if you really want to get the answer. Feel free to try the conditions that we've gotten in all the equations. Just verify or validate if our answers are actually correct. So here becomes 49 minus 4 times 2. We can say, remember, you can always draw this, and then you can have 8, and then we can have 3k, and then less than 0. Just another easy way to solve and avoid unnecessary confusion. So we can have 49 minus 8. So we can go directly and multiply what this is. So this is minus 24k should be less than 0. So if we go further solving this equation, we can have our 24, okay? We can have our 24k let's take the 24 to the other side, okay? So we can have our 49 is less than 0 minus or plus rather 24k. So anything 24k, we can actually plus, it's equals to the same thing at all times. So since this is our 49, we can have 49 is less than 24k. So let's divide both sides by 24. So that means our k or 49 now over 24 is less than k. So if k is if 49 over 24 is less than k, so anything greater than 49 over 24 is actually k. So we can just rewrite this equation as k should be greater than anything greater than 49 over 24. Let's go ahead and see the value in fractions, in decimals, so we can actually understand what exactly it is. So that means in decimals, we can have 2.04. I'll just leave that in two decimal places. So draw my number line, just to make us illustrate what this actually means here. If my k, if this point is my 2.04, anything that's in this part cannot be k, but anything greater here, maybe 3, maybe 4, maybe 5, can be k. So this is the condition k is greater than 49 over 24, or 2.04. Okay, so that wraps it for this video. You have a wonderful day, and thank you.